to your parent. So see here, we were discussing this friction, and in this we had seen that friction is a force which always oppose motion. Okay, so my question is, can friction cause motion? Yes. Does friction causes motion? So the answer is no. Friction does not cause motion. Rather, friction is a force which always oppose motion. Right. So friction is a force that always opposes motion. It acts in a direction. The direction of friction is in a direction opposite to the direction of motion. So the direction in which the object is moving, the frictional force is in a direction opposite to that. For example, it's observed here in the case of books. When the book is moved towards the right, the force of friction acts towards the left. When the book is moved towards the left, the force of friction acts towards the right. Here we observe using this activity of dependence of friction on the nature of surface with the help of a spring balance. So we had also seen here a spring balance, and we had seen that a spring balance can measure mass as well as it can measure the force. Okay. So the spring balance can measure the force also, and the force can be measured in Newton. So here we have taken this brick. We try to pull it with the help of a thread and a spring balance. Right. Now in the first we try to pull the brick just like this, and we observe that how much of force is required to bring this brick in the state of motion. We want to observe that how much of the force is required to have this brick in motion. Then we make some changes like we wrap the brick in a polythene. If we wrap the brick in a polythene, so we observe there that the force of the surface becomes smoother, and hence the force of friction reduces. Therefore, we require a lesser force for the brick to come in the state of motion. Okay. Then the second we had seen here, the second activity, that was the rolling of this cell. We had done the rolling of cell. If you roll down a cell from a starting point, from the same inclination, you have the same inclination and from the same point. First you roll it, you have the base at the table, so it travels a larger distance. In the second case, you put a cloth on the table and again roll. So you observe that it travels a shorter distance. Okay. So why it travels a shorter distance when you have cloth over there?
Sir, because on the rough surface it has more friction, on the smooth surface it has less friction.
Yeah. So on the rough surface, it has more friction, and on the smooth surface, it has less friction. So all these we have understood. Next, we had seen that friction is directly dependent on the load or on the weight. Heavier the object, the greater will be the friction. Lighter the object, the lesser will be friction. And this is the reason why we need to apply a larger amount of force to move a heavy object. If you have a light object, so you need to apply a small amount of. Okay. Now, we see friction a necessary evil. This is another very important friction, a necessary evil. See, these are the two very important aspects of friction. When we are studying friction, if we observe what all things are happening due to friction and what all things are happening bad due to friction. So good and bad things that are happening due to friction, this we will observe. So if we clearly observe our walking, okay, when we walk, so our walking process, during our walking process, if we observe the step by step how we are walking, so during the walking process, we observe, we pull the ground with our feet, we push. So we apply a push. Let's see here with the diagram that how does walking, how we are walking. So walking, just I'll show you a diagram to observe this. Okay, see. Here see. You can see any of these pictures, what happens? No. Okay, I'll let you explain this one. See what happens. You see a diagram which represents different F, N, W. There are different things which are represented there. So we are not interested in all of them. What we need here, what we need to understand here, in this, we need to understand that I am pushing the ground. I am pushing the ground with a certain force. So when I am walking, pushing the ground like this, my applied force or my push, it is this one.
Sir,
So this one is the applied force.
sir, could you
Yes.
explain again, sir? Your screen got stuck and your voice is not coming. This this foot friction. What could you explain again?
Which one?
This the picture right now which you kept on the screen, sir.
Yeah, the structure I haven't explained. Just I'm explaining all. Let me take another diagram, which will be, I think, a better one to understand it. Okay, let's see this one. Okay. Understand this diagram, what happens here. A little part of it we'll try to understand what it wants to say. Okay, see. So see, when we walk, if you try it practically, see how we are walking. While walking, we have to bend forward, and if we don't bend forward, or we bend forward, if we bend forward, then it's easier. But if we are not bending forward, see, we apply a force, something like this, inclined to the surface. We push the ground something like this. If you push the ground perpendicularly, if you push the ground something like this, so your feet will be lifted vertically upward. If you push the ground something like this, so that is the time you will be able to move forward. Okay, so this we call as action and reaction. For every force, there must be for every action, there is an equal and opposite reaction. So when we are pushing the ground with a certain force, our feet also experience a reaction from the ground. Okay, so just try to understand this first, action and reaction. Suppose if you are bearing those roller skates, and bearing those roller skates, you try to push the wall. So what is your activity? Your action is pushing of the wall. You are pushing the wall, and as a result, will you experience any reaction over there? Will the wall also push you or not? Are you getting? Charan Tej?
Sir, can you repeat it again?
See, if you physics says that for every action, there is an equal and opposite reaction. Action means a force that we are applying on a certain object. So this object will also apply a force on us, which will be equal in magnitude. Okay, like suppose it says that if I push the wall also pushes me. Okay, so it seems that no, it's not correct. But once you wear roller skates in your feet and try to push a wall, so will your roller skates and your body be pushed backward or not?
Yes, sir, it will be pushed.
Yeah, it will be pushed. So we can say that for every action, there will be an equal and opposite reaction. Okay, so that's what happening here. When this man is trying to walk, so he is pushing the ground in the downward direction. See, he pushes the ground in the downward direction like this. With his feet, he pushes the ground in the downward direction like this. As a result, he gets a reaction in the opposite direction. So his feet and body will move in this direction. So as a result, we will observe two things. First of all, the feet will be lifted off the ground upward and his body will move in the forward direction. Now he is able to push, the ground because of friction. Had there not been any friction, between ground and the road, he would not be able to push the ground and he will fall off. It is just like you are trying to walk on ice. So if you try to walk on ice, what happens? What will happen if you try to walk on ice?
We slip, sir.
Sir, we will
Yes, what
slip.
will happen?
Sir, we may slip, sir.
Yeah, you will slip off. The reason being, there is very less friction between the road, between the ice and your feet. So friction is not stopping over there. There is no friction. So no one is stopping you. No one is stopping you from moving from falling. But here on the ground, we are able to walk just because of friction. It is friction which opposes the slipping of our feet. So can I say that friction is necessary for walking?
Yes, sir.
Yes, sir.
Yes, I can say that friction is necessary for walking. The reason being, without friction, if I try to walk, my legs will slip. It will slip off, and hence I won't be able to move. Okay. So walking is possible because of friction. So friction is necessary, right? Now we will observe a certain cases everywhere we have friction as a very necessary part. Suppose tying a knot. If you try to tie a knot, so tie a knot. You cannot tie a knot if there is no friction. If you take a frictionless rope, and try to tie a knot, you will not be able to tie a knot. It will open up on its own. It will slip off, it will open up. So every knot you can tie up, you are able to tie up your shoelaces because of friction. Okay, you are able to lock your buttons, shirt buttons, because of friction only. It's the friction force between the button and your shirt that stops the button from slipping off and opening on its own. Okay, so friction is necessary in our everyday life. It is necessary for walking. It is necessary to tie a knot. You cannot tie a knot. You cannot stitch a cloth without friction. Without friction, okay. Have you ever tried to pick an ice cube which has fallen on the earth?
Yes, sir.
It is
Yes,
Is
sir.
it easy? Yeah, is it easy to pull it up?
No, sir.
Sir.
No, because there is less friction. There is less friction, that is why your hands slip off from the surface of the ice cube and you are not able to lift it up. So I am able to lift up a pen. You can see this pen in my hand. That is because of friction. I am holding this because of friction. Had there been not friction, so I won't be able to hold it. It will slip off. Try to hold an ice cube like this, holding it from both the sides. You will not be able to hold it. It will slip off. Got it? So friction is necessary for holding the objects. Friction is necessary for walking. Friction is necessary for tying a knot. Friction is necessary everywhere in our life. You are able to keep objects on a surface because of friction. You are able to ride a bicycle because of friction. You cannot ride a bicycle without friction. Had there not been any friction, so if you try to ride a bicycle, you will fall off. It is friction which help you to maintain your balance when you are riding the bicycle. Yes, Charantej?
Sir, does every smooth object have less friction?
Yeah, all smooth objects, they offer lesser friction.
Okay, sir.
Okay. So smoother
Sir,
object, yes.
sir, I have a doubt. Like the frictions which have less in weight have lesser force, like lesser friction, like that.
Yeah, we just discussed before this. Before this, we discussed that if you have less mass or less weight or less load, so it means a lesser friction.
Like
Like
sir,
we
my network wasn't there properly, and your
okay,
voice was not able to hear. That's it. My network issue.
okay, okay. So
And
it was
then
we discussed that if you try to push a heavy object and if you try to push a light object, so heavy object will be pushed up with a greater force and the light
yes,
object will be pushed with a smaller force.
yes.
So that is
Smaller,
because
smaller object will push it down, sir.
lighter object, smaller force, heavier object, greater force. Because a heavier object will have a heavier
Heavy
force.
weight.
It will have, yeah, it will have a heavy weight and hence a greater force of friction. Okay. Can you think of any other activities which are possible only because of friction?
Sir, I have a doubt.
Yes.
Sir, what is the opposite and equal reaction when we push the ground, sir? For example,
When we push the
when we push the ground, sir, you have here. What is the equal and opposite force reaction on us when we are walking?
I'm not getting what you are saying. See,
What is the equal and
for every action, there is an equal and opposite reaction.
so for walking, what is the opposite force, sir?
Opposite force is called as friction. Opposite force is called as the reaction force.
Like while we are walking, what is the opposite force that is acting on us?
Opposite force that is acting on us. So that means from the ground, that is the friction that is acting. When we are moving forward, it is the friction that is uh, stopping our feet from slipping and it's pulling it backward. Okay. So if we are pushing the feet, by the feet, we are pushing the ground forward. So friction acts and friction avoids the slipping of the feet.
Sir,
So it is the
skating
frictional,
comes under friction.
yeah,
Skating comes under friction.
skating.
Yes, sir.
Uh, will come under that. There are different types of friction. Like we have sliding friction, we have rolling friction. Okay.
Okay, sir.
So these are the two types of friction. You have sliding friction and rolling friction. When you slide one surface on the other, then we say sliding friction. If you roll
Sir,
one object, yes.
sir, so basically the friction just pushes the, like it pulls the object to the opposite direction.
Yeah, friction just pulls the object to the opposite direction of motion.
Okay, sir.
Whatever be the direction of motion, it just pulls the object in a direction opposite to the direction of motion.
Okay, sir.
Okay, that is the only role of friction.
Okay, sir. Thank you.
Okay. So, okay, can you tell me any activities, anything which are possible because of friction? Yes, Sai Karthik. Karthik.
Sir, nothing, sir.
Okay, you raised hands, so that's
Sir,
why
may I,
Sir,
yes,
may I say, sir?
yeah, what, yes. Okay, can we write without friction? Is it possible for us to write with the chalk on a blackboard without friction?
Sir, I want to say
no,
a
sir.
example.
Yes.
Sir, I want to say a example.
The example I said is about the,
No, sir, I want to say a example.
yeah, you can
Sitting
continue.
on a chair, maybe like sitting on a chair. The friction pulls
Yes,
us down, but the gravity
yeah.
will be pushing it up. Like our pressure will be pushing it up. Sorry, like
Mm,
our pressure will be pushing it down, but the friction from the chair will be pushing us up.
no, the friction act tangential to the surface. It does not act perpendicular to the surface. Okay.
Sir,
If
rolling
this is
of
if
Sir,
this
so
is the
the
surface, Yes.
Sir, so this example is not appropriate. It's not appropriate to the question.
No, it's not appropriate. Your example is not appropriate. The reason being that friction is not perpendicular to the surface. We
Okay.
can't say that friction act. Suppose you have your chair like this. This is your chair, and you can't say that friction is acting like this. Friction cannot act like this. Okay.
So it's
Friction
downward.
always act. Yeah, no, not downward. Friction always act tangential to the surface, like this. It can't act upward. It can't act downward.
Okay.
The
Okay, fine.
Yes.
rolling of a smooth object on rough surface.
Rolling of a smooth object on a soil. Yes. See, another very good example is rolling. Rolling of any body. Rolling of any body is an example of friction. If had there not been friction, so rolling will not be possible. Then you will only observe slipping. Rolling action will not be possible. Got it?
Okay, sir.
Any other examples? See,
No,
so
sir.
we listed out here tying a knot. You are able to tie a knot. That's because of friction. You are able to walk. That is because of friction. We observed that rolling is because of friction. Otherwise, no rolling will be possible. Then buttons. Fourth one we have buttons, lock buttons. So yeah, even locks, the working of locks. The working of locks is also an example. It can't work without friction. Yes, yes, Sai Karthik.
Sir, like holding a steering and like moving it also like needs
Yeah, of course,
friction,
of
right?
course. Yeah, if you're holding a steering and moving it, so you can't move it without friction.
Yes, sir.
Okay, so if you are holding it and moving it, that is also friction. Okay, so friction is useful in all spheres of our life. You are able to tie a knot, lifting of a substance. So if you're holding a substance, when we are holding a substance, that is also friction. Okay, you are able to hang your shirt on that hanger. That's also because of friction. Had there not been friction, so you'll not be able to hang it. So holding a substance, that's also friction. Writing on blackboard, so writing on blackboard, that's also friction. Got it? Yes. So these are the various examples where we observe that friction is necessary. Okay. So ruling is possible only because of friction. Tie a knot is because of friction. You can tie any knot without friction. Walking is again, walking is not possible without friction. Buttons, locks, holding of substances, writing on blackboard, writing on your notebook, all of them, they are examples of friction. Had there not been friction, so all these activities, they would not be possible. Then we'll see an evil. Why we call friction to be an evil? So why should we call friction an evil?
So what is evil?
Evil means a bad thing. Something
Yes,
makes us lost.
yes, sir. I know that. Like, why is evil related to friction?
Yeah, why we? Because friction harms us in many ways. It harms
Okay.
us in many ways.
Yes, sir.
Why? You see, you might have seen your parents asking the spare part owners to change the engine oil of your vehicles. Why we change the engine oil of the vehicles? We change the engine oil of
So that
vehicles.
it will
Yes,
make no noise, sir.
see, the engine oil is required over there to reduce friction. Okay, we can reduce friction by using an engine oil. Had there been more friction, so we would have a greater, then there will be more damages. Just try to rub your hands like this. Rub your hands, and do you feel hot? Do your hands feel hot? Something like this, do like this, and
Yes,
just
sir.
take them over here.
Yes,
Do
sir.
they become hot?
Yes,
Yes.
Yes,
Yes,
of
sir.
course.
So why? It's because of friction. So in the same way, if you have your machine parts and if they are rubbed together with a high speed, so do you think a lot of heat energy will be generated over there?
Yes, sir.
And it can lead to potential losses in the machinery. It can lead to breakdown of the machinery parts. In the similar way, so we need to reduce their friction, and to reduce friction, we need oil. So as normal, I think everyone will be able to walk in your house. You are able to run in your house. You can run everywhere in your house. But suppose one of your room is filled with oil. So will you be able to again walk the same way? Will you be again able to run the same way?
No, sir.
No.
No, sir.
Why? Because oil has
Friction, sir.
reduced the friction between the surface and your feet. So if you have less friction, you will not be able to walk and you will fall off. Okay. So
Sir,
we have,
also like,
yes,
sir, lighting a lighter also takes friction, no, sir?
yeah, lighting a lighter is also friction. Okay. But over there, we generally have electric sparks. In a lighter, you have electric sparks which are produced. Got it? So lighting a lighter, that's an electric sparks are produced over there. So got it? Friction as an evil. Evil means friction is something which harms us. So friction is harming our machinery. It is making it break. In the similar way, it is due to friction that our shoe soles, we need to change our shoe soles. They get torn off because of friction. Because of regular use, the shoe soles, they get torn off. That is again because of friction only. It is friction which opposes the motion, and it is friction due to which our shoes are getting worn out. It is friction because of which tires are getting worn out. Okay. So friction is affecting in our life in different ways. It is causing a number of harms. So friction, what are the different things we discussed here? Our shoe soles are damaged, machinery parts are damaged, energy losses are there. So you have energy loss due to friction. Due to friction, you have wear and tear of machinery. That means breaking of the machinery parts. So wear and tear of machinery, energy loss, and shoe soles and tires. Shoe soles and tires, they get worn out because of friction. Hmm. Okay. Can you tell me any other example? Any other example where friction harms us? See, friction is always opposing motion. So had there been not any friction, then your vehicle will not use that petrol. So it is energy loss. You will be able to move as long as possible without any stoppage. Okay. No one can
Sir,
stop you.
losing a grip of tires or
Losing of grip or
tires like any rubber material, sir.
yeah. So that is because of friction only. It's because of friction we are losing all of them.
Yes,
sir,
sir.
It's
even
because
because of friction machines, they make sound, sir.
yeah, machine makes sound. That's energy loss. Okay. So machine sounds.
They will,
Even produces heat.
sir, they will make
Yes.
us slip. They will make us hurt.
They will make us hard. Okay. So noise of machine, that's also because of friction.
That
So our
reduces
friction. Yes.
Produce of heat.
Yeah, friction produces heat, but why, how it is a loss to us?
Sir, means in engines, it produces the heat,
Yeah.
right, sir?
Sir, if the
Yeah.
friction
So,
is too much, you can't move, sir.
okay, if friction is too much, you can't move. Very good. So you can't move. It's not that you can't move.
Sir,
You can move
friction
because,
stops the object.
yeah, friction is stopping the object. So how it is harmful? Sometimes we need to stop the objects. Like if you need to apply the brakes. So if you do not have friction, your brakes will not be applied. Your brakes cannot stop your car.
Or even, sir, like any glass bottles or anything falling down. Like
Yeah.
it's rolling means it, like on the steps, it will fall down and it breaks.
Okay. Okay. So I'll show you here shoe soles and how the machinery parts or tires they get worn out with your regular use.
Sir, they will make us tired.
Hmm?
They will make us tired, sir.
Okay. Just a minute. Just a minute. Just a minute. I want to show you how the tires and become due to friction. See here, you can see the shoe soles, how they have been damaged. Okay. The reason for their damage is,
Sir,
Lack of
loose of
friction.
friction.
Lack of friction.
no, not lack of friction. The reason for the damage is friction itself.
Friction.
If
The
there is
Sir,
friction.
if there
friction,
is too much friction, sir, like the grip will also melt, sir,
if the friction is low,
because of the heat.
no, it's not there. Okay, friction is there, which makes because of which we are losing the our soles due to regular use. Parts of the shoe soles they are getting scratched off, they are getting wiped off. Okay, and after some time we notice a large amount of loss of the shoe soles. In the similar way, we have tires are also
Sir,
getting worn out. Yes, yes.
sir, if mercury falls down, if mercury element is fallen on the floor, it will speedy spread, no, sir, spread on the floor. It will spread on the floor speedily.
Can you repeat your question?
Just send it in chat, sir.
I'm not able to get what you are trying to say.
Sir, his typing is down in the chat box.
Chat box.
He's typing it.
No, there isn't anything in the chat box. Okay, so I hope we have done today this topic. We have done that friction is necessary. Why friction is necessary and why friction is an evil. So friction is necessary in our everyday life because we cannot perform a number of activities. We can't do a number of activities without friction. Okay. Then if there is friction, so it's an evil also. It causes a number of damages like energy losses are there. There is wear and tear of machinery parts. Our shoe soles and tires, they also get worn out because of friction. The noise, our machine parts, they start making noises. Uh, have you ever tried to uh, ride your bicycle and your bicycle makes a noise so that you start oiling your bicycle, and after your oiling process, once you have oiled it, now it does not make any noise and you are able to move it quick silently with less effort. Yes, Amatur.
Sir. Yes, sir.
Amatur, you are not responding. Amatur, Gagana,
Yes, sir.
keep on responding. Okay.
Yes, sir.
Okay, sir.
Yeah, since everyone is speaking, so you should also be speaking. You should also be telling when I'm asking some friction losses and anything. So do give us examples, whatever you can think of. Okay, so in the next class, we will look for how we can increase friction, how we can decrease friction, the different situations where we may need to increase friction and where we may need to decrease friction. Okay, okay, bye everyone. Good night and good
Sir, we
day.
have test
Any
on
questions?
force and pressure rated.
Yes, yes, Karthik.
Sir, we have test on force and pressure rates.
No, you have a test apart from force and pressure, that is generally atmospheric pressure, the pressure part and friction. Okay.
Okay, sir.
So whatever it will be just around 1 to 2 questions from that force, that
Yes.
is pressure and then friction.
Okay, sir.
Okay, bye.
Bye. Thank you, sir. Bye.
Bye, sir. Thank you, sir.